The environment is already breaking you down. You haven't landed yet. You haven't chosen a moon. You're still in orbit, still descending, still deciding, and the radiation is already moving through you. Jupiter's magnetic field is 14 times stronger than Earth's. And unlike Earth's, it doesn't protect you. It traps high-energy particles, accelerates them, and wraps every moon in the system inside a radiation belt so intense it reaches a destructive critical exposure threshold in roughly 24 hours. You haven't touched the ground, and survival is already a physical impossibility. But let's say you have shielding. Let's say you solve that problem. You've made it into the system. You're descending toward a surface. You have to choose a moon. 95 of them. 95 worlds orbiting the largest planet in the solar system, and every single one, in its own specific, creative, almost personal way, is completely uninhabitable. Some will incinerate you. Some will bury you under volcanic rock before you've processed what's happening. Some will swallow you through ice into an ocean 2 kilometers deep in total darkness. Some will simply let the cold, the silence, and the weight of being the most isolated human being in history do the work quietly, over days. This is what the total collapse of survival looks like on every moon of Jupiter. And we're starting with the worst one first. You are standing on the surface of a moon, not Earth's moon, not the quiet, dusty, peaceful place humanity has visited before. Something else entirely. An environment so hostile it feels almost personally aggressive. Jupiter has 95 moons, 95 worlds orbiting the largest planet in the solar system, and every single one of them, in its own unique and creative way, is completely uninhabitable. Survival here isn't just difficult, it's a physical impossibility. The forces at play range from the mundane to events so cosmically violent they barely seem real. Imagine you have no spaceship, no escape route, just a suit, whatever oxygen you brought, and the specific terrible physics of wherever you happen to be standing. This is a journey through the absolute most destructive environments of Jupiter's moons, and we're starting with the most volatile one first. Forget the surface. Forget the geology. Forget everything you think you understand about danger. The moment you enter Jupiter's neighborhood, before you've landed anywhere, the environment is already working against you. Jupiter's magnetic field is the most powerful planetary magnetic field in the solar system, 14 times stronger than Earth's. Unlike Earth's magnetic field, which gently deflects solar wind into beautiful auroras, Jupiter's field traps high-energy particles, accelerating them into a radiation belt so intense it defies imagination. The radiation environment around Jupiter at Europa's orbital distance delivers roughly 500 rem per day. To put that in perspective, a critical, life-threatening dose for an unshielded human body is somewhere around 300 to 500 rem total. You would cross that threshold in approximately 24 hours just by existing in Europa's orbit. Before you've touched the surface, before you've done anything. The moons of Jupiter don't just have their own localized hazards, they exist inside a massive cosmic radiation machine. But let's say you have advanced shielding. Let's say your suit handles the radiation somehow. You've made it. You're descending. You're choosing your moon. Choose carefully. Let's start with Io. Io is the most volcanically active body in the entire solar system. More volcanoes than Earth. More eruptions per year than any other world we've ever studied. Sulfur dioxide plains. Lava lakes hundreds of kilometers across. Volcanic plumes that shoot material 300 kilometers into the sky so high they eject sulfur into space, creating a thin torus of material that rings Jupiter itself. You land on Io, and the first thing you notice is the color. It shouldn't be possible. The surface is yellow, orange, red, and white splotched like a cosmic bruise and sulfur compounds that paint the ground in shades that feel chemically wrong. The air, what little there is, a thin sulfur dioxide atmosphere barely worth mentioning, smells like nothing you've encountered because your suit isn't letting anything in. But you can see what's around you, and what's around you is moving. Io's surface is reshaped faster than any other solid body in the solar system. The ground beneath your feet could be less than a year old. The plains you're crossing could be covering lava flows that erupted last month. You are walking on the freshest real estate in the outer solar system, and it is fresh because the old surface is constantly being buried, melted, recycled, and replaced. But the real danger isn't the volcanoes you can see, it's why the volcanoes exist at all. Io is being squeezed, constantly, by Jupiter on one side, and by the gravitational resonance of Europa and Ganymede on the other. This tidal flexing generates so much internal heat that the moon's interior is a global magma ocean sitting just beneath a thin crust. Thin in geological terms, which means kilometers. But the crust flexes visibly, rises and falls by up to 100 meters in a single orbit around Jupiter. That's a 100-meter tidal wave moving through solid rock every 42 hours without stopping, without weakening, without end. You feel it if you stay long enough, the ground itself, breathing. And then a plume opens 2 kilometers away, no warning, no tremor you'd recognizably interpret as danger before it's too late. A volcanic vent releasing sulfur dioxide gas at hundreds of degrees, mixed with silicate lava that travels faster than you can run, in a place where running is already nearly impossible because the gravity is slightly less than Earth's, but the terrain is fresh volcanic rock that crumbles and shifts and has no interest in supporting your weight. On Io, you die burned, buried, asphyxiated in sulfuric gas, probably all 3 in rapid succession before you fully process what's happening. But let's say you wanted something colder. Let's say you chose Europa. Europa looks from orbit almost serene. A smooth white sphere streaked with rust-colored lines. No enormous craters, no towering mountains, just ice. Stretching in every direction, cracked and refrozen, and cracked again into a surface that looks from a distance like a shattered eggshell that glued itself back together. This is where it gets complicated, because Europa might be the most scientifically exciting world in the solar system. Beneath that ice, somewhere between 10 and 30 kilometers down, there is a liquid ocean. A global ocean, in contact with a rocky seafloor, kept liquid by the same tidal flexing that makes Io volcanic. An ocean that has probably existed for billions of years. An ocean that, by the standards of every life we know, is a candidate for something extraordinary. But you are not in the ocean, you are on the ice, and the ice is not safe. The surface of Europa is one of the most radiation-blasted environments in the solar system. Jupiter's radiation belts dump energy into Europa's surface constantly, splitting water molecules and creating reactive chemicals. The top layer of ice is irradiated into a chemically reactive zone that would be harmful even if you solved every other problem. Your suit handles the radiation, remember. But the surface itself is actively being transformed by radiation, and the chemistry it produces is not friendly to biological matter. The temperature is minus 160 degrees Celsius in the daytime. The ice isn't flat. Up close, Europa's surface is chaotic with ridges and pressure formations. Refrozen disruptions show where the ice below shifted, and the ocean briefly touched the surface before freezing again. There are regions called chaos terrain, where the ice is completely disrupted and refrozen in jumbled blocks and ridges. Those areas make travel nearly impossible. You are not crossing a smooth skating rink, you are climbing through a frozen catastrophe. And then there are chaos regions directly above areas of tidal flexing where the ice is thinner. The flexing is more pronounced where the surface cracks open on a schedule governed by Jupiter's gravity and closes again. You find a crack and stand too close. The ice flexes, opens, and you are in an ocean 2 kilometers below before you understand what happened. You die by falling into the only ocean in the solar system that isn't on Earth, in darkness under ice, crushed by pressure. But that is not the scariest moon. Ganymede is the largest moon in the solar system, larger than Mercury. It has its own magnetic field embedded inside Jupiter's larger field, creating a complex layered electromagnetic environment. That environment does strange things to charged particles in ways scientists still do not fully understand. The radiation on Ganymede is slightly less than Europa's, but still incompatible with long-term survival. The surface is ancient, with dark cratered regions and lighter grooved terrain where the ice crust shifted and refroze. The temperature hovers around -140 degrees Celsius. The atmosphere is a thin whisper of oxygen generated by radiation, splitting water ice and completely insufficient for breathing. You die on Ganymede from radiation, from cold, from the absence of anything resembling survivable atmosphere. It is the most straightforward death on any Jovian moon, almost boring compared to the others. Almost. Then there is Callisto, the outermost of the 4 Galilean moons. In one specific sense, it is the safest since Jupiter's radiation belts thin significantly at Callisto's distance. The surface remains cold and airless and hostile in the ordinary ways of every airless rock in the outer solar system. But radiation that makes the inner moons lethal within hours is reduced enough at Callisto that a properly shielded habitat might theoretically be viable.